In recent months, processes have begun unfolding inside the electric vehicle industry that may appear unnoticed by the general public, but behind the scenes, they are already causing serious tension among the world's largest technology companies. According to several analytical agencies, including Bloomberg Intelligence and Morgan Stanley Research, Tesla's team under Elon Musk is conducting a confidential development program focused on a new generation of battery technologies that could radically transform not only the electric vehicle market itself, but also the entire global energy infrastructure. This is not simply about improving existing batteries, but about attempting to take the next evolutionary step. A step that could finally eliminate the main barrier preventing humanity's mass transition to electricity. Among the many projects being discussed by insiders, one name is appearing more and more frequently: Tesla Cryocell. According to sources close to Tesla's component suppliers in Asia, this is an internal development code associated with a fundamentally new approach to thermal management inside battery cells. Although the company itself has not officially confirmed the existence of such a project, indirect signs suggest that Tesla's laboratories are indeed working on technology that goes far beyond the traditional understanding of batteries. To understand why Cryocell could become a true revolution, it is necessary to understand the main problem facing modern batteries. Any battery is a compromise between capacity, power output, charging speed, and lifespan. But the key limitation remains heat. During fast charging and high loads, batteries heat up. Chemical processes accelerate, the internal structure degrades, and this is precisely what limits the development of the entire industry. Essentially, today's electric vehicle is not only a question of energy, but also a question of temperature control. This is where, according to insiders, the story of Cryocell begins. Unlike traditional cooling systems that use liquid to remove heat, the new concept reportedly involves active management of the thermal state of each individual cell at a microscopic level. Sources claim that Tesla is experimenting with materials capable of instantly absorbing and redistributing heat, creating what is described as a quasi-cryogenic stabilization effect. This does not mean the battery is cooled to extremely low temperatures like in scientific laboratories, but rather that local overheating, which is one of the main causes of degradation, can be dramatically reduced. Moreover, according to information appearing in Goldman Sachs analyst reports, Tesla is actively investing in research into phase-change materials inside batteries. These are substances that can change their state while absorbing large amounts of energy without increasing temperature. In theory, this allows the battery to operate in a mode where heat does not accumulate, but is constantly redistributed and partially returned to the system. This very effect has led to the emergence of a term now actively discussed in technology circles: regenerative cooling. If these developments truly reach the stage of a commercial product, the consequences could be enormous. First, charging speed. Today, even the most advanced electric vehicles are limited by thermal constraints, but Cryocell could potentially allow a battery to charge from 10% to 80% in just a few minutes without the risk of damage. This would effectively remove the main advantage of gasoline-powered vehicles: refueling speed. Second, battery lifespan. According to insiders, one of the project's goals is to create a battery capable of withstanding hundreds of thousands of charging cycles without significant degradation. This means that a vehicle could operate for decades without replacing the battery, while the battery itself could later be reused in energy storage systems. The third factor is power output. Cryocell could open access to entirely new levels of energy delivery, allowing electric vehicles to achieve performance characteristics that today seem impossible. Acceleration, stable operation at high speeds, and the absence of overheating even under extreme loads. All of this becomes possible with effective temperature management. But perhaps the most important aspect is that Tesla is not viewing Cryocell solely as an automotive technology. According to the Financial Times, the company is increasingly moving toward becoming a global energy player, and new batteries could become the foundation for large-scale energy storage systems. This means Cryocell could potentially be used in power grids, homes, factories, and even at the level of entire cities. However, the path to such a technology will not be simple. The main challenge is cost. Phase-change materials, complex thermal management systems, and new cell architectures all require enormous investments and significant time to scale. In addition, there is the question of reliability. Any new technology must undergo years of testing before it can be safely introduced into mass-market products. This is why most analysts agree that if Cryocell truly exists, its market appearance is unlikely before the end of the decade. But even the fact that such development is reportedly underway is already affecting the industry. Tesla's competitors, including Chinese giants and traditional automakers, are accelerating their own research programs, realizing that the next breakthrough could completely change the balance of power. For Tesla itself, the launch of such a technology could become the moment that finally solidifies its leadership. If the company becomes the first to offer a battery that eliminates the main weaknesses of current solutions, it could create an effect comparable to the release of the iPhone in the mobile device world. The market could literally restart, and those who fail to adapt may be left behind. But there is another scenario that experts are increasingly discussing. If Cryocell proves too complex or too expensive for mass production, Tesla could initially use the technology in premium products or energy solutions, gradually reducing costs and expanding the scale of application. This approach has already been used by the company before and has proven effective. In any case, even if some of the information about Cryocell turns out to be exaggerated, the overall logic of technological development suggests that the industry is indeed approaching major changes. Limitations that until recently seemed fundamental are gradually beginning to disappear, and companies like Tesla are at the center of this transformation. And if even part of what insiders are currently discussing turns out to be true, the coming years could become a period when batteries stop being the weak link and become the main driver of technological progress. And that would change not only automobiles, but the entire structure of modern civilization. This is why the project known as Tesla Cryocell is already being viewed not simply as another development, but as a potential turning point, after which the world of electric energy could become completely different. But the story does not end there. As information about the potential cryocell technology begins to leak into the professional community, it is not only the perception of Tesla as an automaker that is changing, the entire logic behind evaluating its future is changing. Previously, the company was compared with traditional automotive brands, later with technology giants. But now an increasingly common view is that Tesla could become something much larger, a new type of infrastructure company controlling one of the key resources of the 21st century, energy. And this raises one of the most debated questions. What will happen to the market if Tesla really gains a technological advantage of this scale? According to analysts at ARK Invest, even a small lead in battery efficiency could create an exponential effect, because batteries are the foundation not only of transportation, but also of the entire digital economy. Data centers, artificial intelligence, autonomous systems, all of these require stable and affordable energy storage. In this context, Cryocell stops being just a battery for a vehicle. It becomes the foundation of a new energy architecture. Insiders claim that Tesla is already discussing scenarios in which the new technology would be integrated into completely new products. This includes next-generation modular energy systems, capable of providing autonomous operation for homes, businesses, and even small cities. Imagine a system where energy is not simply stored, but intelligently managed, redistributed in real time, and with minimal losses. This is no longer Powerwall in its traditional form. It is a complete energy ecosystem. But perhaps even more ambitious plans are connected with future transportation. According to sources close to Tesla suppliers, the company is considering using Cryocell in projects beyond the automotive industry. Among the discussed areas are electric aviation, autonomous cargo platforms, and even new types of transportation systems that have not yet been presented to the public. And if even part of these plans becomes reality, Tesla could enter markets where completely different players dominate today. However, with potential comes pressure. The higher the expectations, the greater the risks. Within the industry, people are already beginning to ask whether Tesla will be able to maintain the pace it has set itself. The history of technological breakthroughs shows that the transition from laboratory development to mass production is the most difficult stage, and it is exactly here that many revolutionary ideas encounter reality. One of the key challenges is scaling. Even if Cryocell works in a laboratory environment, it must be adapted for millions of devices, ensuring stability, safety, and predictability under all operating conditions. This requires not only technological solutions, but also a complete transformation of supply chains, manufacturing processes, and quality control systems. According to Reuters, Tesla is already holding discussions with a number of chemical and materials science companies to secure access to new types of raw materials that may be required for the implementation of such batteries. Another important factor is competition. Chinese manufacturers such as CATL and BYD are actively investing in their own developments, including solid-state batteries and new chemical compositions. South Korea and Japan are also conducting intensive research, and if Tesla is truly moving toward Cryocell, it could trigger a new technological race comparable to what we have seen in the semiconductor industry. At the same time, some experts remain more skeptical. They point out that the terminology surrounding Cryocell is still too vague, and many statements can be interpreted in different ways. The industry has already seen cases where ambitious concepts turned out to be only intermediate stages and never reached mass adoption. Therefore, some analysts urge caution and warn against overestimating the current leaks. Nevertheless, even skeptics admit that the direction Tesla is moving in follows the natural logic of technological development. Improving thermal management, increasing energy density, extending battery lifespan, these are inevitable steps, and the only question is who will achieve them faster and more effectively than everyone else. This is exactly where Tesla has traditionally demonstrated its ability to take risks and break established approaches. Interestingly, Elon Musk himself has recently started speaking more frequently about the fundamental limitations of batteries and the fact that overcoming them is the key to the future. Although he has not directly mentioned Cryocell, many analysts believe that such statements could be an indirect indication that the company is working on something truly significant. If we try to look further ahead, the consequences of such batteries extend far beyond a single company. This could change the structure of the global economy. Countries that gain access to advanced energy storage technologies will receive a strategic advantage. This will affect energy, transportation, industry, and even geopolitics. Energy independence is already becoming a key factor, and Cryocell could potentially strengthen this trend. But there is also a less obvious side. If batteries become significantly cheaper and more efficient, this could accelerate automation and transform the labor market. Electrification of transportation, robotic manufacturing, autonomous systems, all of these become more accessible when cheap energy is available. This is no longer just a technological issue, but a social one. Inside Tesla itself, according to sources, the company is also discussing the consequences of such a transition. Tesla understands that reaching a new level requires not only technology, but also readiness to manage its impact. This includes cooperation with regulators, creating new safety standards, and building trust among users. That is why many experts believe that even if Cryocell is still at an early stage, its development is already shaping the future of the industry. It has become a kind of focal point around which the strategies of the world's largest players are beginning to form. And perhaps the most important question is not whether Cryocell will appear, but when it will happen and who will be ready for that moment. Because if the technology truly proves viable, it will not simply change the market, it will reshape it completely. And then Tesla will no longer be viewed merely as a leader in electric vehicles. It could become a company that defines the rules of the energy world. If this scenario becomes reality, we will no longer be talking about competition between automakers, but about a battle for control over a new energy reality, where the battery is not just a component, but the foundation of everything. The further this story develops, the clearer it becomes that we may be witnessing not just another stage in the evolution of technology, but a potential turning point after which the familiar picture of the world could begin changing much faster than ever before. Because at the center of everything is energy, And whoever controls energy controls almost everything. In recent weeks, experts have begun discussing another important aspect related to the potential cryocell technology. It is not only about production and application, but also about patent activity. According to specialized databases, Tesla and affiliated research groups have filed several applications that indirectly describe new methods of thermal management in battery systems. The wording is intentionally broad, but several key concepts repeatedly appear: phase transitions, local stabilization, and control of heat flows at the level of material structures. All of this forms a picture that increasingly resembles the very concept insiders have been discussing. If this is combined with Tesla's activity in the fields of supercomputers, artificial intelligence, and autonomous systems, it becomes clear that this is part of a much larger strategy. The company is not simply creating a battery, it is building a system where energy, computing, and transportation merge into a single ecosystem. And this could become the factor that separates future leaders from everyone else. But there is another element that makes the situation even more interesting. According to information circulating among venture capital funds, Tesla is allegedly considering the possibility of partially licensing certain elements of the new technology. This means the company could not only use cryocell inside its own products, but also profit from spreading the standard, effectively transforming itself into a platform. And if this actually happens, Tesla's influence could extend far beyond even the energy sector. At the same time, the industry is increasingly discussing a cautious but important question. What if cryocell is not the final goal, but only an intermediate step? Some experts believe Tesla could use this technology as a bridge toward even more radical solutions, including completely new types of batteries that today exist almost at the edge of science fiction. And if that is true, then the current discussions may only be the beginning of much larger changes. Against this background, the perception of time itself is also changing. In the past, technological revolutions took decades. Today, the cycle has been reduced to just a few years. That is why leaks, rumors, and indirect confirmations are beginning to play a much larger role. They allow markets to prepare in advance, shaping expectations and investment strategies long before official announcements. And here we reach the most important element of the entire story: uncertainty. No one knows exactly how far Tesla has progressed, what the real specifications of cryocell are, or when the first products based on it could appear. But the very fact that such a technology is being discussed at this level is already changing market behavior. Companies are accelerating, investors are reallocating capital, governments are reconsidering their energy strategies, and all of this is happening before the technology has even been officially presented. This is the true sign of a major shift, when the future begins influencing the present before it has even arrived. If we try to imagine the moment when Tesla finally reveals cryocell, it will most likely be more than just a presentation. It could become an event that establishes a new benchmark for the entire industry. Just as the iPhone once changed the way people viewed smartphones, a new generation of batteries could change the very definition of what energy means in the modern world. And then the question will no longer be how good the technology is, but who will be able to adapt to the new reality. Because in a world where energy becomes cheap, stable, and practically unlimited, the rules of the game will change for everyone, from automakers to technology giants and entire nations. That is precisely why more and more analysts today are converging on one conclusion. Even if cryocell turns out to be only part of a broader strategy, its significance already extends far beyond a single development. It is a signal that the next technological wave is already forming, and it will be tied not only to artificial intelligence, but also to how we produce, store, and use energy. And that raises the most fundamental question that remains open. Are we ready for a world in which energy constraints no longer exist? Because if the answer turns out to be yes, the consequences could be far greater than anyone expects today. And perhaps the most underestimated aspect of the entire story is how quickly such a transition could happen. The history of technology has shown many times that when a critical mass is reached, change does not occur gradually, but in sudden leaps. And if cryocell does emerge even in a limited form, whether initially in premium models or energy solutions. It could become a trigger after which the entire industry begins to reorganize at an accelerated pace. At that moment, the market will no longer compare specifications of individual cars or batteries. A struggle will begin for access to the technology itself. Companies will be forced either to catch up, form partnerships, or completely rethink their strategies. And it is precisely in such periods that new leaders emerge while old ones disappear. Some insiders directly say that within Tesla, scenarios are already being considered in which Cryocell becomes not just a product, but a new entry point into the company's ecosystem. By purchasing a car, a home, or an energy solution, the user effectively connects to a unified system where everything operates on the same technological foundation. This creates an effect that is difficult to replicate, the effect of full integration. And if this scenario is realized, Tesla could move to a level where competition with traditional automakers no longer matters, because the discussion would no longer be about cars, but about control over energy, data, and infrastructure. And that is exactly why today, despite the lack of official confirmation, the topic of cryocell continues to gain momentum, because even the possibility of such a technology is already changing market behavior, investments, and expectations. And thus, the main conclusion that analysts are gradually reaching becomes very clear. We may be at the very beginning of an era in which the battery ceases to be a limitation and becomes the key to a new technological reality.